Now let's explore morphology and segmentation operations. We learned before that in image processing, we perform certain operations on an image or a video frame to enhance it or to extract meaningful information. Morphology and segmentation are two techniques of image processing. Morphology is a broad set of image processing operations that explore images based on shapes. In a morphological operation, each pixel in the image is adjusted based on the value of other pixels in its neighborhood by choosing the size and shape of the neighborhood pixels. So you can construct a morphological operation that is sensitive to specific shapes in the input image. Image segmentation is the process of partition an image into parts or regions. So this division into parts is often based on the characteristics of the pixels in the image. For example, in this flower in the slide, one way to find regions in an image is to look for discontinuity in pixels values, which typically indicates edges. These edges can define regions, and other methods divide the image into regions based on color values or texture. And in this example, we can see 3 different regions. So let's see examples of these techniques. In this slide, we will process one image with a structured element and a rule. So here we have a dilation of with 3 pixels line. So here the operations tries to enhance the white pixels in the image. So you see on the right what is the output. So this structural element of line is going through all the image and building this dilation of the white pixels. Well, if you want to do the erosion, this also applies when you have these white pixels and you want to remove these white pixels of the image. So for example, this is something that you apply when you have salt and pepper operations, we call. Now, suppose we want to count the white regions in this image. If we zoom into the center, we can see that the image is grayscale, even though it appears from far to be binary. As a first step, we have to decide where one region ends and another begins. On the right, we see simple threshold-based binarization, but even here, we can see that counting blobs is potentially problematic. In a 4-connected analysis, every diagonal of clusters is considered to be a separate region. This leads to a significant overcounting of regions. On the other hand, in an 8-connected analysis, these diagonal pixels are considered the same region, leading us to undercount the regions. If we apply image clear border and image open functions, we will see a bare image to count the regions. Segmentation refers to the process of creating masks of an image, such that regions of interest, called ROIs, having similar traits are assigned to the same value. Segmentation uses the association between pixels in the image. The associations or regions of interest could be based on intensity, color, texture, shape, position, or anything else. Binary segmentation separates the image into 2 classes, true or false. But you can actually make any number of segmentation masks for a single image, as you can see here with the flower example. They're separated in 3 regions, and the rice grains are separated in 2 regions. So now let's see segmentation techniques that enable extraction of meaningful information. So here we have the binary mask of the rice grains. We still have some rice grains that are connected here, for example, and also here. So this will count when you try to find the regions. We count this one rice grain, but it's not. So we need to apply some erosion here to better count this, if our task is to count the rice grains here. And another application is the optical character recognition. You see the text from the normal image, you cannot see the text, but if you extract it and apply some operations of segmentation, you can see the text. Visual inspection, and also image-based pathology, when you can count, segment what is cells and what is the other substance in the image. Also, you can do some thresholding. So for example, here you just have the separating the cones that are red, yellow, or blue. These are apps for morphology and segmentation you can find in MATLAB. This is the image morphology file exchange. It's available in the file exchange. And the color threshold is available in MATLAB, the image segmenter, and the image region analyzer.